Cool. Hello, nice to meet you. I am Sebastián Castro. It's my first time here in Austria. I am quite excited to be here. Today I'm going to share with you a research I have made on Windows persistence, and I have named it RID Hijacking, Maintaining Access on Windows Machines. I would like to thank to Bettina and all the people that make this possible. Besides the technical problems, everything is great. So this is about me. I am an InfoSec nerd. I like the exploit development. I am also a Windows security enthusiast, or not an expert, in fact. I am 25 years old, so my first Logon was 25 years ago. And as you can see, I like to draw in Paint. I'm the current technical and research lead at CSL Labs, which is a company that mainly works on providing pen testing services to companies that work in the financial sector and the local defense government agencies. I have been working on the field as a red teamer and pen tester for maybe 6 years. And I have presented also this specific research also in Black Hat this year, also in DerbyCon. And I'm planning to present this also on other conferences this year. So before taking a look at the agenda, I would like to say that this particular technique got media attention right after my talk at DerbyCon, but I have seen that some people misunderstood the attack. They understood that this is a privilege escalation technique, but it is not. It is a persistence technique, which means that you already need a foothold on the machine you are compromising via this technique. So we'll check this later. Let's take a look on the agenda. So first of all, I am planning to expose the attack and how it looks like. After that, I am planning to show you how does the Windows security architecture works, mainly related to the Logon process. In the third part, in hijacking the RID, I will point out where exactly are the security issues that makes this attack possible. After that, I am planning to do a live demonstration. I hope it will work. And against a Windows 10 machine I have updated last night. So yeah, this is currently reliable on every Windows machine. There is no currently official patch for this. And after that, some final conclusions. And of course, I'll be glad to answer your questions at the end of the talk. So let's meet up the RID hijacking attack. What is this? As I have told you, this is a new post-exploitation vector, which is reliable on every Windows operating systems since NT. I have tested it from Windows XP to 2012, and Windows XP to 10, and Windows Server 2003 to 2012. I haven't tested it on Windows 95. It is hard to find a 95 machine at this moment, but if you can try it and let me know if it works. It will create a stealthy access on the targets, all by using only OS resources, meaning that we don't need any noisy extra file that may trigger any alert on the victim. It takes advantage of some integrity issues I have found on the Windows security architecture, and it is currently reliable on domain joint machines, but not on domain controllers yet. I am working on a similar attack. Okay, so in short, this attack will modify the relative identifier of an existing account and will set it up to another one. Just the relative identifier, meaning that all the other security properties, such as the password hash, the account status, etc., will keep consistent before and after the attack. By hijacking the relative identifier at the exact place, the privileges will be spoofed. And one cool thing is that no matter what the hijacked account status is, active or no, the hijacker account will retrieve its privileges as on. So keep in mind that only the relative identifier is modified, so an attacker could log on with a specific set of credentials he already owns and get access as another user. And also, depending on configuration, it will be possible for him to access via PSXEC, via RDP, and so on. And besides the privileges stealing, the system will register any operation which has taken place during the hijacker session as done by the spoofed account. And of course, this technique is reboot persistent, so it's pretty cool. Yeah. So this is how it looks like. In this image, we can see that we are running a CMD as the guest built-in account. I have enabled it for these purposes. We can see that we are still members of the guest local group, but we have writing permissions over a protected folder, such as the system32, which is awesome. Yeah. So to understand the magic behind this, I will briefly explain how the WinLogon process works. So I know, I told you I'm terrible at Paint. Well, this is to elucidate the concept, you know. I think that Windows architecture is pretty similar to the security concept of some buildings you have been on. So these buildings, you introduce yourself in front of a tough guy by giving your name or showing up your ID. The person in charge will verify if you are registered, and if you are, then he provides you an access card that will allow you to get into the floors you have permitted to. So let's assume that the green guy will be the representation of the administrator built-in account. This red girl will be our main character that will represent an unprivileged account, for example, the guest one. This bad blue guy will represent the Windows security, and this ugly building, the Windows operating systems. Let's imagine that inside this building there is an RFID-alike control system which is based on the access card that the blue guy provided you. To keep it simple, of course, I have drawn 3 floors to represent the privileges you can get inside a Windows system. I know there are a lot of more, but it's pretty hard to draw them all, okay? So depending on their access card, users shall enter inside some specific floors. In a more technical way, this is the Windows security architecture related to the Logon process, but as you can see, we're ignoring by now the modules related to the Active Directory authentication. That's because the RID hijacking attack takes advantage of the way that Windows handles the local user's authentication process. So we are going to be focused by now on the LSASS, the MSB10 DLL, and the SAM server DLL, okay? I think that many of you have seen this image before. In a nutshell, elegant task is like this. So when a user authenticates through WinLogon, the LSASS will verify his credentials and will create an access token to identify the security context with the help of a kernel process mode, which is called SRM, Security Reference Monitor, sorry. This is, as I have told you, a security kernel process mode, which is connected with the LSASS, and it's responsible for creating this access token and defining the security context of the user. Also, when the user is trying to access an object, the security reference monitor is in charge of verifying the access token against the access control list of the object the user is trying to access. This process of checking is also done by using security identifiers, which are stored on the access token and also on the ACLs of the object. Here is the structure of a security identifier. These are the way that Windows has to differentiate or identify security principles such as users, computers, groups. As you can see, the first part in yellow is the one which differentiates of the machine or domain, among others. But the last one, the relative identifier, can be the same across all machines. For example, in every Windows machine, many of you have maybe know that it is the 500 relative identifier is associated with the administrator building account, the 500 one with the guest one, and so on. So let's suppose that the administrator wants to log on in a system machine. So he provides its username and password to WinLogon. To do that, Windows needs to initialize some task and connection between processes. Right after, Logon calls Logon UI to grab the entered credentials using a credential provider. That will define the way that the credential will be grabbed. In this case, if you're using a combination of user and password, we will use the Auth UI credential provider. With this information, Logon will create a unique identifier, which is called Logon SID, to identify this specific Logon attempt. And if the authentication Logon attempt succeeds, this will be added to the access token. And now Logon retrieves a handle for an authentication package, which are used to verify the authentication policies of a Logon attempt. So remember that we are focusing on the MSB1 DLL. So Logon will send this information to the authentication package called MSB1O, and we'll send the combination of the username and password hash with the created Logon SID. And then this critical step of the authentication process, the MSB1O will send the user password combination to the SAM server, which will retrieve the related security information, including the user security identity. And now, to sum it up, the MSB1 checks the information retrieved. If it is OK, generates another identifier, which is called LUID, for this current session, and sends back the local information to LSA-SS, including this identifier. All this data will be used by the security reference monitor to define the security context of the user. So we'll see that in short. Now that everything is OK, the Windows Security Subsystem proceeds to create the access token for this recently authenticated user. The access token is the way that Windows has to define, as I have told you, the security context, particularly on a process. This object is created by the security reference monitor with the LSA-SS for every user session. It's also important to know that every child process inherits a token copy of the creator's one, meaning that every process within a user session will be executed with the same access token. So going ahead with this authorization task, the LSA-SS receives the Logon information from the authentication package MSB1O and checks up its own database, which is the security registry Hive, to determine the user's allowed access. This check is done by using the security identifier of the user. Right after, LSA-SS will add the initial token to the initial access token, the associated groups, security identifiers, and privileges associated with the user. And finally, the primary access token is created. So later, Logon will call user init and other libraries and executables to initialize everything based on this security context. And then let's say that the user gets the access card, and he can get, in this case, into the VIP zone with his own access token. Cool. Pretty simple. OK, yeah. OK, so now that we went through the Windows standard Logon process, let's take a look at the thing we are interested in. Where in the process do you think is something exploitable? So it is important to recapitulate by question. So how is the user identified by the system after being successfully authenticated? It is identified by his security identifier, or SID, which is unique within the host. How does the system associate a username with his security identifier? With black magic, of course. See, this is one of the things I have fussed and reversed and debugged to find the security issues that make the RID hijacking possible. So let me show you how this works. So do you remember this part of the authentication process? Here is the exact moment when a username is translated to his associated security identifier. And then some important data is obtained from the SAM. So how is the username associated with the security identifier? And what security information is retrieved? The SAM server knows how to translate from username to security identifier. So he goes into the SAM database, which is the registry Hive we all know, and selects the username on this. Let me see, where is it? OK, here. We can see this is the specific registry key that is queried by the SAM server DLL. Each of these keys contains a registry binary, as you can notice here, and these reg binaries have an attribute which is called type. This attribute contains the hexadecimal version of the relative identifier associated with the user which is being queried. So in this case, it is 3E9, which in decimal base is equal to 1001. Sorry. Now that the SAM server knows the associated relative identifier, he looks at this specific register place and chooses the one whose name is the same relative identifier with some significant zeros. Then it grabs all the information is stored into this specific referenced key, and the SAM server sends back all this data to the MSB1 authentication package. This is the security data that is returned back to the authentication package. So after understanding this process, some questions may arise. Why does the SAM store only the relative identifier? Because every user or every security principal will have the same SID initial part, but the relative identifier will always be different for each of them. The only thing that varies from user to user or security principal to security principal is in the same system is the relative identifier. What information is retrieved from the SAM? The data obtained from the SAM, from the registry specifically, contains the password hash, the account status, and some account restrictions, and the pivotal one, a copy of the user RID. This is the core of the RID hijacking. We will see that in short. So let's exemplify the attack. Let's do the authentication process with the guest account. But now we will omit some parts of the authentication process and explain in more detail the exploitable ones. So remember that guest is just an example. This can be used also by using standard local users account, because it is easy to detect that the guest account is active, but it is not that simple to detect that a standard local user account has been compromised via this technique. Okay? So let's omit the beginning, when Logon has done his job, and send the Logon information to the authentication package, MSB1, and now MSB1 sends the user hash combination to the SAM server. Now SAM server queries the SAM database looking for the associated guest key. It determines that the guest account has the RID 501 or 105 in hexadecimal. So SAM server queries again the SAM, but now consulting the 0000001F5 key. Now the process retrieves the security data related to the user, including this particular RID copy. I told you it is important. After that, SAM server sends information back to the MSB1 authentication package, and this guy does his job. So this could lead to two possible scenarios. The first one is that our hacker girl will not authenticate because on every Windows machine, the guest account by default is disabled. So we got an access denied. On the other hand, the second scenario is that supposing that for some reason the guest account is enabled, the guest account can authenticate against the machine, and she will receive her access token, and then, well, she doesn't get kicked out, but has only access to the guest floor. So how can we improve this situation? It's a mystery for us right now to understand why there is a copy of the relative identifier inside a registry binary on the SAM registry hive. What would happen if we modify this? So I have found that this relative identifier copy, which is stored inside the registry, is the value used by the LSASS and the security reference monitor to create the primary access token. So the privileges added to the access token are obtained based on this relative identifier. So let's set this RID copy with another RID. In this case, we are switching from 501 to 500, which belongs to the built-in administrator account. So now repeat all the process. MSB send the user hash to some server queries the SAM database with the guest username. Then it retrieves it associated RID key 105. Now queries again the SAM database with the obtained RID. And now it receives the security data from the SAM, including this modified RID copy. This data is sent back to the MSB authentication package. And now, continue with the authentication process. The MSB package checks for restrictions for this specific user obtained from the SAM as the security data. The thing is that MSB 1.0 takes the status of the guest account, but assumes that they are from the administrator, allowing the access, even the administrator account is disabled. So as I have told you, maybe you have kept that in mind, is that the only thing that I have changed is the RID, not the other security properties. So if the guest account is enabled, it will assume that the administrator is enabled. This also applies to the hash. So MSB will compare the cached version of the entered password hash and the hash retrieved from the SAM. Profit password will be the same. Now that everything is OK, the authentication package retrieves the logon information to the LSASS, and then the LSASS communicates with the security reference monitor to create the access token based on this modified RID copy. So all the security properties of the account remain the same, except the RID, which is the critical one. Modifying the RID at the exact place it's equal to acquiring the privileges of the spoofed account and doing everything you want. The guest account receives her access token, and she can do anything inside the system on behalf of the administrator. So what are the security issues involved with this technique? The first one is that the SAM server does not check if the relative identifier which is associated with the user is consistent with the RID copy. The second one is that the LSASS does not corroborate the RID with the username before creating the access token. And the third one is that the LSASS never looks for RID inconsistencies during the user session. So this is the fun part, demonstration. I hope it will work. This is the complex structure of the demo. So we are trying to interactive logon against a Windows 10 machine. We are planning to do this using also IT-SECX. I think we will not do the RDP. And we are going to use Kali Linux to automatize the attack. I have developed a model to automatize the RID hijacking. So these are the virtual machines. As you can see, we have updated this last night. Let's see. Yeah. Perfect. OK, what happened? Maybe some of you don't trust me, so here are the authentication hotfixes, the authorization, the updated hotfixes. There you go. Here's the machine. These are the users, the local users, remember. So this is the administrator built-in account. This is the guest account. This is one unprivileged account, which is a standard local user account. So let's see the privileges of these users. No, yeah. We can see that the account is not active, which is good. It is a member of the local group administrators. For the demonstration, I have activated the guest account. We can see here that it is only member of the guest group. It is active by now. And let's see the unprivileged account. It belongs to the user's local group, and it is also active. So let's try to lock this. And let's try to authenticate locally. Interactively, I mean. I have set this password.1, okay? So it will try to authenticate. It will say that this distinct method is not allowed to this user, to the guest user account, which is good. So to automatize the RID hijacking, I have developed a Metasploit module, which is available on the latest official version of Metasploit. You can access it to post Windows manage RID hijack. This is the model. So these are the options available to this model. So it will be this Boolean will be the get system. Will try to acquire the required privileges to modify the registry binary we are planning to use with the RID hijacking attack. The guest account Boolean will define if we are going to use the guest account as the attacker one. The password, if we want to change the password of the attacker account. The relative identifier we are planning to set, in this case by default, is the 500, which belongs to the administrator built-in account, and the meta-interpreter session that we are planning to use. Since this is a post-exploitation technique, this module requires a meta-interpreter session. So let's try to set this. Set get system true. Set. Well, let me show you the session. This is the meta-interpreter session we have. So set get the guest account true. We're going to use the guest account. And before executing it, let's try to do a PSXX against the machine with the guest credential. We can see here that we are trying to authenticate with the guest account and the password. So if we try to do that, we will get a status logon type not granted. Okay. It is not possible to authenticate remotely using the guest user. If we try to execute this, okay, we have modified the relative identifier associated with the guest account. In this case, we have set the 501 to the original RID 501, which belongs to the guest account. So let's try again to authenticate interactively with the guest account. Okay, there is no magic still now, because it is possible for us to authenticate interactively. But if we try to authenticate again with the guest account by using PSXX, it will be possible for us to authenticate with privileges. Maybe some of you know that the in-packet version of PSXX tried to get the most privilege, the highest privileges. Sorry. So in this case, this shell is running a system with the guest credentials. Okay. Yeah, we're authenticating as guest, but we can get a shell as a system. So this is the interactive session using the guest credentials. We can see that if we run a who am I, we can see that, yeah, we are guest. Let's take a look about the access token. If we see the access token, we can see that it is the demo guest, the local user guest, but the relative identifier is 500. So we can do something like, let's say, echo IT-SECX to, okay. See. And we can have writing permissions to this, to protected folders by using the guest credentials. So type, yeah, we can write it down. We can do everything, and every action that takes place during this session. Let me zoom it up. Okay, everything that is done during this session will be registered as executed by the administrator. But let's take a look about the privileges of this account. So if we do something like net user guest, we can see that we are still members of the guest local group. Okay. If we take a look at the administrator built-in account, we can see that it is not active. So we are doing something like an administrator, but the administrator is disabled. Maybe some of you guys something like some graphical things. So this is also available on L-User Manager. We can see that the administrator is disabled. If we take a look at the guest group, this local group, sorry, we can see that it is still also members of the guest group. And also the administrator is disabled. Okay. This is also reliable, as I have told you, on standard local users account. I don't know how many time do I have remaining? 0? Okay, no. So let's imagine that it works also on local users, okay? Not built-in local users. So, by now, there is no existing patch to protect Windows from this attack. I have received some emails from the Microsoft guys. They recommend me to clarify that this requires a foothold on the machine because this is not a privileged escalation. The only way to defend this of this kind of technique is by detection. So I have tested it. Have tested this with many antivirus solutions, endpoint solutions, but it is not detected. The only thing that antivirus detect are the meterpreter session. But this, as I have told you, this can be done with only OS resources. This is more complicated on big Windows domains. You know, since a simple workstation can have this and can be the backdoor of an attacker. I am not currently aware about any malware using this kind of technique to persist the access. And, well, as you can see, this is quite simple. So, and it's pretty easy to apply. So I hope you will enjoy this technique as much as I do. And thank you for coming, OK?